Okay, so I hope I'm audible. So, good evening, everyone. This is the last lecture of the NPTEL interactive sessions for the course Air Pollution and Control. So, this lecture is for week 11 and 12 questions. So, since in 11th and 12th week, like the lecture series, so it is about COVID-19 lockdown and the effect of COVID-19 lockdown on the kind of pollution that around us, or legislations, and then it's about all these pollutant, for example PM 2.5, VOC, SO2, NO2, and the instrument we generally use to analyze them or measure them. So uh, these things pretty much sum up the 11th and 12th week. Now if in terms of in terms of numericals, there are questions that is already, I think, given in week 12, which is there are simple formulas, and an example is given. So here we'll see some of the questions from week 11 and 12, and then if you have any doubt, you can ask me. So let's start. So there is a discussion in week 12 about the multi-gas monitor, uh, which is nothing but a device which generally used in the laboratories to measure the to measure gas. um, so generally when you say multi-gas monitor, it means that there will be lot of like measurement of multiple gases. But the thing is that whenever you have measurement of any particulate matter, irrespective of if it's a gas or a PM or VOC, whatever, there are few things that we need to measure along with it. So generally these things, which is temperature, humidity, and dew point, these are three parameters which you will find in most of the measuring instruments, because it's like when you are collecting gases or any particulate matter or VOC, for example, your instrument need to know that what is the temperature condition, what is the humidity at that time, at that particular hour or minute, for example, and like what is the dew point. So temperature everyone knows, humidity we know that what is the level of moisture. Now dew point is that uh, for any gas to convert into vapor, right? So for example, if a water has to condense or become vapor, it needs like 100% saturation, right? So dew point is that temperature or that point when the gas convert to vapor phase. Not no, the vapor, sorry, the vapor converts into the liquid or condense. Okay, so that is what you call as dew point. So in any instrument you need to know that what is the temperature, what is the humidity, what is the dew point. And then if it's a multi-gas monitor, you measure different gases. Here two of the major gases are carbon monoxide and CO2. Sometimes there is measurement of SO2, NO2, for example. It depends on what, how specified this monitor is. Okay, so these three things are very common. Now, next is why CO2 is measured in just a second. Okay. So, along with these multi-gas monitor, there is another type of analyzer, or you can measure CO2 using the non-dispersive infrared spectroscopy. Okay. Now, why you can, so if anything, for example, generally gases like N2, O2, you cannot measure them using spectroscopy, because the principle of spectroscopy is light. Okay, if a how a molecule behaves in presence of a particular wavelength light, that determines that if it will be measured by a spectroscopy or not. Okay, now the thing is that CO2, irrespective of other gases, which is N2, O2, that is there in the atmosphere, CO2 can be measured by this non-dispersive infrared spectroscopy. It's an instrument which works on the principle of IR. So where you put IR light on the gas, and then depending on how the gas behaves, you measure what type of gas is it, for example. So the reason CO2 can be measured is because it has a property of absorbing. Okay, because we know that CO2 is one of the greenhouse gas, right? And the principle of greenhouse gas is that uh, in general principle of greenhouse gas effect is that the light, okay, which reflect back from the earth's surface will be absorbed by these gas or particle, whatever there is in the atmosphere. So the light which comes is generally UV visible, and the light which goes out is IR. So this CO2, which is one of the major greenhouse gas, has the capacity or ability to absorb the IR radiation, and generally they absorb into far IR. Okay, which is about it start from I think 500 micrometer to 1 mm or something. So CO2 generally absorbed at this wavelength, 15 micrometer. So this is important. Now, why? Uh, if you know that any gas, for example, or any particle which absorb light, it depends on its vibration. Okay, so generally they say that when you see NO or O2, sorry, not NO, N2 or O2, the vibration is only one way. It's either apart from each other or either towards each other, right? But the thing is, for CO2, okay, they can have equal pull or push on both end, or they can have, it can have unequal push or pull. It means that from one side there will be more uh, push compared to the other side. Okay, or the third type of vibration CO2 can have is the up and down motion. So CO2 can move up, or it can move downwards. Okay, so depending, because the vibration of CO2 molecules is like it's a very complex vibration. It can show multiple type of vibration. That is why it absorb light, and it absorb mainly in the far infrared region, which start from around 15 micrometer. Now next is isokinetic sampling. So I think this again is a principle that is used in some of the gas analyzer. Now, what do we understand by this term, which is isokinetic sampling? So kinetic or kinesis is a term which is used for motion, right? Or something which is moving. So when I say isokinetic sampling, it means that in a gas analyzer, let's say a gas is entering, okay, because any instrument, or for example, if you take PM 2.5, if you take a gas analyzer, the principle is that there will be a pump. The pump will suck the air from the atmosphere, and whatever particle or gas is there in the atmosphere, they will come along with the air and enter the instrument. So the principle of isokinetic sampling is that the velocity and the direction of gas in the chamber, or in the gas which is coming, or the air which the instrument is sucking, the velocity and its velocity and direction will be similar or same as of the surrounding. Okay, so it should be same. If for example, if this is the rooftop and this is my gas analyzer, it has a cyclone here which is taking the air in. Okay, now the direction of air which in this cyclone, let's say air should move in this direction, because if the surrounding air is moving in this direction, then the movement of air or gas inside this analyzer should be in the same direction, in this direction only, and should have the same velocity or similar velocity as of surrounding air. That is the principle of isokinetic sampling, because we are saying that the motion of gas outside of the sampler and inside the sampler is similar. So the gas is behaving same way both outside as well as in the analyzer. Okay, so that is one thing you should remember. Now next is that there is CO2 analysis. So not CO2, SO2 analysis. So SO2 is a gas. So these are tiny questions. It could be um, so the thing is that if you have we have done, I think every one of has done that. The sulfur generally gives this very pungent sort of smell. So the SO2 similarly has this burning matchstick kind of smell, and it is kind of an indicator. It's not like carbon monoxide, which is basically odorless. It has a smell. So if there is any uh, burning around you where there is a lot of SO2 being produced, you can actually identify, because it like has the same smell as of a fire when you burn or light a matchstick. Now to measure it, they have used or to measure it, they have used something which is called potassium tetrachloromercurate. So this complex actually is used to measure SO2, because gas generally you cannot see. So what they do is that they have like a system. They collect the SO2, they compress the SO2. Okay, once the SO2 is compressed, it is dissolved in a solution of potassium tetrachloromercurate. Now once it is dissolved, it react with the solution and formed something called dichlorosulfutomercurate complex. And if this is formed, it means that you have a sulfur dioxide in the air. So how you can understand is that, let's say if this is a gas analyzer and it is taking air, okay, lot of air is like depositing collected in this region. Now after this, what they have something called which condense the gas or which liquefies the gas. Okay, because you cannot directly, there are some instrument which directly measure gas, but sometimes what you do is you liquefy the gas, and then you have something called like beaker or apparatus or whatever, which has this TCM, potassium tetrachloromercury, and this gas will goes into this beaker which has this TCM. Now if in this beaker something like dichloro, this complex will be made, then we can say that this chamber has lot of SO2. If this complex will not be made, you cannot say that SO2 is released or formed. So this is important. Now NO2 is generally, we know that NO2 comes from fertilizer, it comes from agriculture, it comes from this uh, decay of plant or plant processing. But it's a very, like, there is very few people who actually study about this, where this gas is actually formed from lightning. So the thunderstorm that we have, thunder and lightning, so when the lightning strike, so in the path, so let's say this is the top of the atmosphere, this is the bottom, and this is the atmosphere, like, and lightning comes from top and hit here. Now this path which light travels has lot of gas molecules, and their reactions take place between the gas molecule to give a gas which is NO. But this NO further react, because it has a short lifetime, it react with oxygen, gives NO2. Okay, so it generally happen in this region, like in the path only on that portion where the lightning strike, because in the light, in that region the temperature is very high. Okay, so the gas molecules vibrate, the thermal energy is so high that they vibrate, they separate, and then a new molecule will be formed. Okay, and the another question is same. So they, I think they have said something called sodium hydroxide and sodium arsenate, which they use to liquefy, to transfer this NO2 into a solution which has this sodium hydroxide and sodium arsenate sort of solution, and when it goes, it gives something called nitrite ions, it forms nitrite ions, and those nitrite ions, they will be measured further, or their concentration will be measured. Again, this can also be done using spectroscopy, and for that the wavelength is 540 nanometer. 540 nanometer is visible, so you measure nitrite in visible region compared to CO2, which we measure in infrared. Okay, so NO2 dissolve in something called, I think, sodium hydroxide and sodium arsenate, and then they gives nitrite. Now next question is that what, so this I took from an equation. So generally if you have gone through the questions, you see that for SO2, even though the process of SO2 and NO2 is almost similar, the difference is that in NO2 they also use sampling efficiency to measure the concentration of these ions or NO2 gas in general. And sampling efficiency is that if you are taking, let's say, one, okay, if I use, instead of this, if I say one, so or you can say, in, let's say, in the case of SO2, they have not used anything, so at, I think, you can consider that it is one, okay, or is it, they are considering that there is 100% efficiency of SO2 sampling. But the thing is, in NO2 they have used a sampling efficiency which is 0.82, which is only 82% efficient. This method is only 82% efficient. So sometimes in the question they can ask that if the method that you are using, if it has a particular sampling efficiency, then uh, how the concentration varies, because The better the sampling efficiency, the more the number of molecules that you see or that you measure. And as the sampling efficiency decreases, the number of molecules or the concentration also decreases. Um, okay. Next is, so we've been saying particulate matter for I don't know how long, since the beginning of this course. So what exactly is particulate matter? So it has a very simple definition, which is any solid particle. Solid means anything which has a sort of structure or a size in the atmosphere, and liquid, and or both of them suspended in air. That is particulate matter. So as I said that particles can exist themselves, okay, as for example, the simplest thing is that if I burn a paper, tiny black things will be like emitted, so, right, those you can consider that as particle. So they can exist as themselves, or what they can do is they can combine with water vapor, then lot of gases will stuck to them, or they will have, okay, or they can completely undergo reactions and form a new product in the atmosphere, a secondary product. So they can exist themselves, they can live as a coagulation with gases and water vapor, or these particles can react, or these gases can react in the atmosphere to give a completely different product. So that is particulate matter, that all of these three combination can exist, and that is why it is a mixture of solid, liquid, or both the particles suspended in the air. Now PM 2.5 samplers, so we have multiple types of particulate matter samplers. Some measure the total suspended particles, some measure only 2.5, some are low volume samplers, some are high volume samplers. So the difference is, for example, if it's low volume or high volume, the difference is the amount of air intake, okay. So in per minute, how much liter an instrument can take in or can suck, it determine if it's a low volume sampler or a high volume sampler. Okay. So for example, in low volume, the rate of flow is I think 16.7 liter per minute or something like that. In high volume sampler, it's way too high. Okay, it's way too large. So that is the major difference between them. Now another difference is the cut point. Okay. So in some of the particulate matter analyzer, the cut point is 2.5. In another, there is 10 micrometer. Some goes up to 0.25 micrometer. For example, the for indoor pollution, we use something called cascade impactor, which can go as low as 0.25 micrometer. So depending on the cut point of the sampler, there are also different types. Okay, but the basic principle of all the sampler is same, okay, and that is inertial particle size separator or inertial impaction, I would say. In the last class, we discussed that inertial impactor is nothing but, for example, if you see these low volume or high volume sampler, you see that they have like a big sort of structure at the top, and then they have a tube. So what they do is this, the air comes from the there is pump at the bottom, and then here there is a filter, we put filter, and then there is a monitor which measure the readings. So once the pump is on, this thing suck the air, and now air inside air move like this, okay, and since air moves, it collide with the walls of these um, um, the top, okay, or the this, what do you call it, this tube. Okay, so that is what inertial impaction is, that if something is moving, okay, and has lot of inertia, lot of energy, and it strike the wall of the container or among themselves, it loses its energy and fall. Okay, so all the PM 2.5 samplers actually work on this principle, that they suck the air, the air moves in circular motion. Okay, it has an inertia. Now as it keeps on moving, it it collide with the wall, and then the particle which loses its inertia falls and collect on this filter plate. So this is the principle, which is inertial impaction. Okay. Now next is this portable aerosol spectrometer. So portable aerosol spectrometer is that sometimes you use it in fields. Generally, spectrometers are big instruments, so you cannot take these instruments to the field, or to, let's say, to the rooftop or somewhere. So portable aerosol spectrometer help us like measure these particles for in a short time, and you can carry it, like you can carry it in field. The only principle is that it works on the principle of scattering. So you have particle, they come, okay, um, you have a filter, the light strike the filter, some of it is absorbed, the other will be scattered back. Okay, so this scattered, the light which is reflected or scattered from the particle will be detected or will be measured at 90 degrees. So um, if light strike on it, okay, a bit of it is absorbed, and other light will be scattered, let's say in this direction. Now in this, it has, let's say, a mirror or an optics at 90-degree angle. Okay, and then it strike here, and then it changes its path, and then here there is a detector. So you have a particle, like light strike, whatever it has to absorb, it absorb, other it will scatter. The scattered light will strike this mirror at 90-degree, and then it changes its direction towards the detector or diode, you can say. And you measure the light absorbing property or scattering property of the aerosol. So the simplest answer is that it works on the principle of scattering of light. Okay. Now, whenever we see this PM 2.5 sampler or any other sampler, for example, we always say that okay, it has a cut point of 2.5, it has a cut point of 10, it has a cut point of 1. But we need to understand that what is cut point. Okay, so generally, what you say is that it's very hard for an instrument to achieve 100% collection efficiency. Okay, 100% collection efficiency means that if, let's say, air is coming into a PM 2.5 sampler, okay, now air can have particle of various sizes, right? And I am saying that this instrument only measure particles of size less than 2.5 micrometer. Okay, if I am saying that an instrument is measuring only uh, if an instrument is measuring only particle with size less than 2.5 micrometer, it does not mean that other size particle does not enter the system. They did. Okay, they are there. But what they do is, whenever they say that it has a cut point of 2.5 or a cut point of 10, it means that it collects particle of less than 2.5 size with 50% efficiency. That if I have a sampler and lot of particles are being deposited on the filter paper, then more than 50% of those particles will have a size of less than 2.5 micrometer. Not all of them will have a size of less than 2.5 micrometer. Only 50% or a little bit more than 50%. Okay, so that is how you define a cut point, that if an instrument can have 50% or more than 50% collection efficiency, you can say okay, it can have a good collection efficiency, you can put it as 2.5 or 10 or 1, whatever, depending on uh, the type of sampler. So this is what cut point is. Cut point is the diameter of the particle at which it can collect at least 50% of the particle of that size. Okay, मिनिमम 50% होने ही चाहिए वो पार्ट उस साइज के पार्टिकल्स. दैट इज व्हाट इट मीन्स बाय कट पॉइंट. सो दिस I believe you should understand this. Next is about, I think, okay, NCAP. So NCAP, we've been studying multiple times this, but NCAP is the National Clean Air Program. It started, I think, recently only. The only point of NCAP is to curb or decrease the target, this PM 2.5 or 10, to about 20 to 30% less. Okay. Now, see, I think here what is important to understand is that generally uh, the agencies or the organizations try to make sure that they have a program for different type of species. Okay, they have a program for ozone, they have program for gases, they have program for this PM 2.5, PM 10. So because, and the reason for that is that, of course, they have a combined effect, they all of them is causing air pollution, but the important thing is that they individually are very important to stop them, because some of them can be easily controlled or easily sort of maintained so that the pollution will be reduced. And that the biggest example of that is COVID-19 lockdown. In the COVID-19 lockdown, even though we have the CO2 concentration which is high, no one can touch CO2 because it's still there, and it is still causing the greenhouse gas and everything. But the thing is that these pollutant which has a short lifetime, they decrease with it like a tremendous percentage. Okay, so that is why this NCAP is started, which is for only PM 2.5 and PM 10. Now it has again limitations. So I have put limitation here. I will generally say that, see, for any program, the limitation is first, it's whatever you start, even if it's a government agency or government has started a program, everything is legally binding. Okay, it means that if you are saying that you will reduce ozone, uh, tropospheric ozone by 50% in next 5 years, then you are basically bind by the government of India. You're bound by government of India ki okay, why you have not done it in 5 years. So it's whatever statement you make, you have to make sure that it is attainable. Okay, so that is why it is legally binding. And sometimes this thing does not follow through. Okay, so that is that is when the problem arises, that you give targets and the targets will not be met by the end of that time period. Next is absence of compliance mechanism, that there is no strict hard and fast rule that okay, uh, I have to reduce PM 2.5. I am stopping manufacturing of this, or I am stopping these type of industries or this type of power plant. No, you cannot do this. There are no, you can make regulations, you cannot make rules very easily. Okay, so that is another problem. Next is data related implementation hurdles, because see, we, even though we have a lot of monitoring sites in across India. Okay, but the thing is that there are a lot of drawbacks of that data also, because sometimes you don't have consistent data. Sometimes people, uh, it's not reliable, or it's very different, or the instrument, there is no maintenance of the instrument, so the data you might get is not reliable. So there is a lot of hurdles you have to go through in terms of data. Sometimes you don't find people to actually go and set up the, like, do the collection every day. And since A very tiny example of this is, let's say they are collecting this PM 2.5 using low volume sampler across India. Okay, they have but now this CPCB is in the center, right? And it is saying they cannot go everywhere to collect the filter sample, right? They have assigned people to collect these filters from let's say Kolkata, Delhi, Chandigarh, Bangalore, whatever. Now now the difference start is that when for example, when I collect PM 2.5 sample, the idea is that lot of things I need to make sure. For example, I need to make sure that the filter should not have moisture, the filter should be baked, I should not touch the filter without gloves, it should be weighed properly 3 times, then it should be put in the desiccator to avoid any after filter moisture. Then every now and then we need to check on the instrument that if it's working properly, if it's not, is it has a flow rate of 16.7 or not, because sometimes if the instrument has issue, the flow rate changes, right? So even though they have set up these many system across India, the thing is not every instrument can be maintained, because not every instrument can have these scientists or PhD just for that instrument, working for that instrument, because everyone has their own PhD or postdoc or whatever sort of work, or as a scientist or a professor they are working. So that is another issue. Third is urban and rural disparity. Now it's very important, because generally, if you see, these instruments are set up in the towns or in the cities. Okay, if you go into a very isolated rural region where there is not much infrastructure or buildings or something, or let's say colleges or university, you will not see any of these instrument there, because they have to, like, first is you have to sign these MOU and everything with the CPCB or government of India. Next is that you don't find in the rural location, like extreme rural or remote location, you will not find the engineers who will like set up this and then will take measurement every day. So the most of the data that we have currently is from, like, 80% is from the urban region. So, and for the rural region there is very limited, and that too from the town region, like from the developed areas of rural location. So there, that is why there is disparity, because the kind of pollution that you see in urban region is very different from the rural region. I will explain it this thing in the next slide also, that how it's different. So that it's still not solved, that why like how to reduce or resolve this disparity. And last is the financing, because setting up 50 or 100 of the instrument, and each instrument, let's say if the minimum cost is, let's say, 3 4 lakhs, it is a huge budget. So finance is also another drawback or the limitation. Now everyone knows IKEA. I think IKEA is this furniture manufacturing or sort of company which gives affordable and good furnitures. I think it's based in Bangalore, I don't know. But so what they say is that along with the government agencies, there are different organizations, for example, NGOs or these companies like IKEA, they have started these initiative to curb pollution or to reduce pollution. So one of the way is this initiative, which is Better Air Now. This initiative, what they do is they have these rice straw, like waste which comes after harvesting rice, and they use it to make raw materials for their furniture or their home decor or house products. Okay, so that is one. Now, what are the benefits of green mode of transport? So the thing is, what is green mode of transport? So green mode of transport is nothing but when you use any transport without fuel use, or without, you can say, without uh, non-renewable fuel use. Okay, so if for example you cycle, you use these rickshaws, or you use electrical autos or something, then what you are doing is you are using this green mode of transport. If you are walking, that is also a green mode of transport. So the benefit, generally green mode of transport in India, it's not very, what you say, very well used, but in other countries people emphasize on the use of cycles or bicycles as a transport mode. So the benefits are low carbon footprint. Okay, so the carbon emission of course will be reduced. Then energy consumption is less because we are not using any fuel, or if the fuel that we are using is electricity which is renewable. Next is there is no emission, and it's very cheap compared to the if you use bikes or cars or whatever. Okay, now they have discussed something about ethanol blending. So it is recent somehow, which is that instead of the proposal is that instead of these petroleum and diesel, you can use these alternative uh, fuel, which is ethanol, which you can mix with the other fuels, and can have high efficiency and low emission. Okay, so that is what ethanol is. That ethanol is the it can be used in transportation fuel. Still there are people, like, it's still not finalized, but they say that 20% of ethanol blending is possible. It means that you can mix 20% of ethanol to the fuel that you are using, any fuel, petrol, diesel, whatever, and it can give better, let's say it will be better for the environment and has low emission. Okay, they have something similar to it about methanol also, but it's still, these things are still very recent and need to be developed further. Now another thing is this crop residue burning. So crop residue burning is a method which generally used in the this northern part of India, which is Haryana, Punjab region, UP, where the farmers burn their crop residue after harvest. So what they do is they, as soon as the harvesting season is over, whatever is left they burn. They prepare the soil for the next season. Now the thing is that because uh, you are burning the biomass, because agriculture residue or crop residue is nothing but biomass, large amount of biomass in a very short time, then the pollution, actually pollution spikes in that time. If let's say the normal temperature is normal particulate matter concentration is 20 microgram, in that time the concentration becomes like 100, 120, 140 microgram. And another problem is that they are not polluting their region, they are polluting the entire Indo-Gangetic plain, that entire stretch of Haryana, Punjab, Delhi, UP, Bihar, West Bengal, that entire stretch actually will be affected because of burning in only in this region. Now there are certain methods that is being devised to reduce or to decrease the residue burning. So what they suggested is, you can, whatever you get left after the harvest, you can use it as a manure or the compost for the soil. Or there is something called biochar. You can make sort of, biochar is actually has a lot of, what you say, scientific properties, because it actually, first, it can retain metal. There are studies which are still going on that biochar is actually has a capacity that of retaining metal and metal complexes. So that is why it is important, if you take the crop residue, you process it, you convert it into biochar and use it in your soil or for harvesting. Okay, now another thing is fluid catalytic cracking. Okay, so I think it is generally used in industries. Okay, or oil industry, for example, the principle is that there are a lot of waste, okay, or heavy product that is generated after the distillation of oil. Okay, so what you do is the waste that is, so once you are extracting the oil from the ground, there are a lot of waste generated. What you are doing is you are converting that waste with the help of different catalysts into the high grade product. So sometimes people make these rubber products and all of that, they are made using this technique, which is fluid catalytic cracking only. Hmm. Next is this, which is the most potent energy to transmit heat into the water molecule. It is same, which is infrared, because water molecule is also there, right? Is one of the greenhouse gas. So you consider it this way, and water molecule also has a structure which is similar to CO2. So you can understand that this H2O actually uh, absorb, or you can say is actually react to the infrared rays or FIRs. Now there is discussion of different type of technique which is used in different cities to reduce the pollution. So I think the important thing is that there is very tiny, for example, what is the principle that, on which it is that that technique function, and what it reduces. I think these two things are very important. For example, this street murals in Mexico, so they used a paint which actually absorb pollution, okay, and among all the pollutant, it's very effective for this gas, which is NO2. It is seen in Mexico that in region where there is lot of street murals painted with this new technique, they have a high reduction in the NO2 levels. Okay, of course they might absorb other type of gases or particles, but this gas is majorly affected. So that I think you need to know. Another is this biosolar leaf, which is used in the London. So I think it is in Imperial College, or I think UCL, I don't remember, but in one of the university or colleges in London, they have designed this biosolar leaf. It is nothing but solar panels which are designed, which are basically green and designed in the form of leaves. And what they do is that they work on the principle of photosynthesis, that they absorb the gas and they release the oxygen, like convert it. Okay, so this you can remember. Last is this smoke reducing granules. This is used effectively in USA, and this functions as a so they have something called photocatalytic coating. Okay, so if you have something, a coating which can be activated or which react with the UV rays, okay, then what they do is that these granules, once they come in contact with UV, they generate these radicals. And so if these are granules and it has these photocatalytic coating, the air which comes in contact with these granules, okay, they bind, okay, and there is sunlight. So now as soon as the sunlight come, these granules become activated. Okay, they have these tiny radicals on all over its surface because of this photocatalytic coating. And then whatever chemical or whatever secondary product there is in the atmosphere or air which comes in contact with these granules, that transformed into this water soluble ions, and that wash away in rain. Okay, so what you are doing is that in regions, let's say during, especially during winters when there is a lot of smoke, you have these uh, sheets of these granules, and then the air come in contact with these granules, they convert it into convert the chemicals in the atmosphere into water soluble ions, and then if sometime it rains, it it washes away everything on this surface. Okay, and then these granules become like new only. So they are used, or they are being used currently in USA now. The last slide. So the thing is that what we need to know, what is an efficient fuel. Okay, so to determine if any fuel is efficient or not, you need to know two things. First, the amount of smoke it is generating. So if it's a low smoke fuel, it's good. For example, LPG is a good fuel, or an efficient fuel compared to wood. Okay, would generate lot more smoke compared to LPG. Second is calorific value. Calorific value is something which is used to measure the efficiency of any fuel, irrespective of like any burning fuel, I would say. So, calorific value is that we generally know that when a fuel is burned, it has heat energy. Okay, so how much heat energy a fuel can generate, that determine how efficient it is. Because uh, if, let's say I burn, um, let's say there is LPG and there is wood. Okay, now 1 liter of LPG gives a heat energy of um let's say 100, and wood on the other hand, 1 kg of wood gives an heat energy of 500. So wood is more efficient. But the thing is that the other thing, which is the smoke, also comes into play in that case, that if would generate smoke or not. So whenever you define a fuel as efficient, it depends on its calorific value, that how much heat energy will be generated by burning a particular amount of fuel, and how much smoke a fuel can generate or is generating. Okay, next is so this is simple, that what this avoid shift improve approach in transportation. Avoid is that you avoid lot of traveling. Shift means that if you have, so shift means that if you are traveling by your personal car, then try to go by public transport or by these e-vehicle or something. Third is improve. Improve means that if you are not following this public transport thing, then improve the quality of fuel you are using, do the pollution control, uh, avoid overspeeding, all of these things. So use better technology for the pollution control, all of that. So it's simple. Next is this COVID lockdown thing. I believe this is actually a very, so in the cases that is being that were discussed, so there were a lot of cases from Brazil, I think, London, India, Mexico, I think there are like a lot of Spain, I think so. A lot of countries were discussed about that, how the COVID lockdown was there in this country, and how that lockdown affected um, how that lockdown affected the type of pollution that is there. So I think of all the cases that were discussed, the important thing was that we see that lot of pollutant were decreasing. Okay, NO2 is decreasing, PM 2.5 is decreasing, SO2 is decreasing. Like, and it is seen in every country, irrespective of if it's India, if it's Brazil, if it's London. In whichever country there is lockdown, there is a decrease in the concentration of pollutant. The reason being that people are not outside, there is less traffic, there is less burning, because people are not doing this what you say, there is so the burning is maybe if there is any forest fire. Okay, so the idea was that when you stop the man-made activities because of COVID-19 lockdown, the pollution that is generated by the man-made activity also reduces. Okay, so it's not like it's end. Okay, ऐसा नहीं है कि 100 मतलब 100 माइक्रोग्राम था PM2.5, तो 0 माइक्रोग्राम हो गया, नहीं, it becomes let's say 50 microgram. It reduced because what we are stopping is only man-made activities. The natural activities which leads to pollution are still there. Okay. So, and in all of the cases, we see that the concentration of NO decreases in all of them. But the important thing, except like all the pollutant, there is this one pollutant which increased in every country, irrespective of lockdown, and that is tropospheric ozone. Now, there are three reasons. So, these reasons are combined among different countries. There are different reasons given, but it's like combination of any three of them. Okay. So, first is that generally NOx help in the ozone production also, ozone consumption also. Sorry. So, we have seen, or I think I have discussed that generally the ozone concentration is high during the daytime because ozone requires energy, UV visible energy for its generation. Okay, so generally O3 is high during the daytime, and the concentration of NO is higher or NOx is higher during the night time. So what NOx does is that for the production of NOx, you need ozone. Okay, now generally what happen is that it will not directly form NOx, right? There need to be release of other uh, NO, like NO substituent, right? So, as I said, I think in the previous slide only, that NO is being released and then it will combine further in the atmosphere with oxygen or ozone, with oxygen radical, and then gives this NO2 or NOx. So, for this NO to convert into NO2, you need ozone radical, which comes from you need oxygen radical, which comes from ozone. Okay. Now the thing is that if the production of NO is decreased, the carbon nitrous oxide is decreased, then however much this O radical is there, the production of NO2 will not be there. ओके, सो क्या हो रहा है कि NO2 तो बढ़ रहा है, NO2 तो कम हो रहा है क्योंकि NO है ही नहीं, नॉक्स है ही नहीं एटमॉस्फेयर में, एंड क्योंकि नॉक्स के बहुत सारे सोर्स फॉसिल फ्यूल और ये ट्रैफिक वगैरह है, सो नॉक्स इज नॉट देयर इन द एटमॉस्फेयर. सो दिस ओजोन इज बिल्डिंग अप बिकॉज ओजोन यूज ही नहीं हो रही है, कहाँ यूज होगी, नॉक्स तो बन ही नहीं रहा है. सो फर्स्ट इज दैट. ओके, मैं सेकंड डिस्कस करूंगी, उससे पहले आई विल डिस्कस थर्ड पॉइंट विच इज दिस, दैट photochemical reaction, favorable condition for the photochemical reaction which increase due to increased solar insolation. Okay, now if there is no pollution in the atmosphere, what will happen? Whatever the sun radiations are, they are directly coming. So the idea is that this H nu is more stronger compared to how it was when there is pollution, because when there is pollution there are a lot of particle to participate or to take this solar energy or solar insolation. But because there is, the sky is clear, there is no pollutant, so this solar insolation is lot more, so sunlight is there, and sunlight is the one of the primary way, or one of the catalysts you can say for the formation of ozone. That is why ozone is formed. Now second reason is actually depends on the location. Okay, so if you measure in the rural and urban location, the concentration changes of ozone and for NOx also. The reason is that there is something called VOC limited and NOx limited regime. Okay, so when you say that a region or a locality is NOx limited, you say that the pollution in that locality is affected or is will increase or decrease depending on the NOx, okay, NO2 or NO. Or you can say the pollution is sensitive towards NOx. A slight change, a slight increase in NO2 or NO, or slight decrease in NO2 or NO will change the pollution in a region. Similarly, VOC or volatile organic compound limited is same. It means that a slight change in VOC will increase or decrease the pollution. Now we know that another thing we know is this VOC react with NOx to give these secondary carbons or secondary organic carbon or secondary aerosol, you can say SOA जिसे हम बोलते हैं. सो इन अ रीजन, ओके, एंड अगर एक रीजन में नॉक्स बन रही है तो उस रीजन में ओजोन तो होगी, बिकॉज ओजोन तो बन ही रही है इन जनरल, क्योंकि द मोर दी सोलर इंसोलेशन द मोर ओजोन इज बीइंग फॉर्म, क्योंकि ऑक्सीजन की तो कमी नहीं है एटमॉस्फेयर में, तो और सोलर इंसोलेशन मिल ही रही है तो ओजोन तो बनेगी. अब इन अर्बन रीजन, अर्बन, नाउ व्हाई अर्बन रीजन इज वीओसी लिमिटेड, क्योंकि okay, the first thing is that in both remote or rural location or in urban location you can see the formation of SOA, okay, or secondary pollutant, you can say. The problem is that because in villages or rural location the VOCs are very like too high concentration of VOC, okay, because you can get, first is that there is tiny bit anthropogenic VOC can be there. Anthropogenic means man-made VOCs are always there in every location. The thing is in rural location the biogenic or the plant based VOCs are too much, okay. The more agriculture, the more plants are there, the more biogenic VOCs are there. So, and the NOx concentration is less in the villages. In urban location, the because there is lot of traffic, okay, the NOx concentration is very high generally, and the VOC concentration varies. So you can say here the VOC is very high, here the NOx concentration is very high. So the pollutant does not depend on this. They depend on the concentration which is less. So here the concentration which is less is NOx. Here the less concentration is VOC. So in region where, so the second point that the decrease in NOx, okay, it's a decrease in NOx will affect the VOC limited environment, which is this, because ऑलरेडी VOC कम है यहाँ पे और अब NOx भी कम हो गई, okay. In a region where already VOCs are less and now NOx is already decreasing, what will happen? There is no uh, no sink of ozone left. So that is why, that is one of the reason why urban ozone increase compared to rural, because in generally if you see the in the COVID trend, जो विलेजेस है ना वहां पे इतना इफेक्ट नहीं हुआ है, क्योंकि विलेजेस में पहले भी मेजर पॉल्यूटेंट क्या होता था, खाना बनाने की वजह से आ रहा है, या फिर जो एग्रीकल्चर बर्न होने की वजह से आ रहा है, या पेड़ जला दिया, इन सब चीजों की वजह से आ रहा है. ट्रैफिक की वजह से वहां पे इतना पॉल्यूशन था ही नहीं, विलेजेस में नहीं है. लेकिन अर्बन रीजन में क्योंकि नॉक्स की कंसंट्रेशन के चेंज होने के साथ वहां का पॉल्यूशन चेंज हो जाता है, टाइप ऑफ पॉल्यूटेंट चेंज हो जाते हैं, इसलिए इट वाज इम्पोर्टेंट. इसीलिए वहां पे ओजोन की कंसंट्रेशन ऐसे वेरी कर रही है कि ओजोन की कंसंट्रेशन इतनी हाई है कि मतलब यू कैन नॉट अंडरस्टैंड, बिकॉज नॉक्स है ही नहीं, वीओसी ऑलरेडी कम है, नॉक्स है ही नहीं. क्योंकि वीओसी कहाँ से आ रहे थे, वीओसी मैक्सिमम जो अर्बन लोकेशन में आते हैं वो होते हैं मैन मेड वीओसी या एंथ्रोपोजेनिक वीओसी. अब मैन मेड एक्टिविटी हो नहीं रही है, देयर इज नो ट्रैफिक, सो वीओसी खत्म, नॉक्स ऑलरेडी खत्म क्योंकि ट्रैफिक नहीं है, सो ओजोन इंक्रीज. So I think this is very important to remember that ozone concentration increase हुई है in COVID lockdown in all the different cities or countries, whatever, and these are the three major reasons for this increase. Okay, now other questions are pretty simple. One is that there is a agreement which is devised or dedicated to the ozone layer, and that is Vienna Protocol. And Vienna Protocol में there is something called Montreal also, and they are, the basic function of them is that they have to fill that, or they have to make sure that over coming 20, 30, 40 years, that ozone hole over Antarctic will be uh, filled or will be reduced. Okay. Next is, there is a protocol for SO2 emission, which is Helsinki protocol. So these are things you have to remember. uh, there is no other way. You just remember that which protocol is helpful in which, for which emission. Okay. And I think that will be it. So for Helsinki it is SO2, for Vienna it is ozone. And in Montreal protocol is actually a part of Vienna itself. And there is this something called Kigali amendment, which was done because initially the ban was only on CFCs, which is chlorofluorocarbons. But in 1987, this thing, which another amendment was made to reduce even the hydrofluorocarbons. Okay. Because even if they are less harmful than CFCs, they are still harmful for the ozone layer. Okay. And the last is for the reduction of VOC, which is Geneva Protocol 1991. So you can, there are, of course, there will be more there. How you can remember it is, you remember the type of pollutant it is curbing to and the name. And I think that way you will remember these. Okay. So I am done for today. If you have any questions, just a second. Uh, okay. Okay. Mm, a project topic I don't understand. Can you explain a bit? What sort of project you have to do? What? Okay. S- So you have to do project, but like you don't have to do experimental thing, right? O- okay. If, see, the thing I asked is that if you have access to the instrument, then your project could be around those instrument. If you have access to the sampler, if you have access to the gas analyzer, so that project could be around them. And otherwise, if you have like if there is no access to the instrument, then you can work on the satellite data. That way also is possible that you have, there are different NASA satellite, Modis, Mera, all of these. You can download the data, like multiple so what generally people do is that they download multi-year data from the satellites, and then they see how the trend is. And how, for example, a simplest example I would say that, let's say you download organic carbon data, for example, from Modis or Mera, these satellites which are there, the data is like publicly available. You take that the concentration, and you see, let's say you collect data for let's last 10 years, and then along with that you collect data for temperature, humidity, or whatever factor that can affect the organic carbon from the satellite, or from these CPCB or like centers. They have the temperature or the gaseous data, whatever data you get. So the idea is you collect datas, and then you see that how the concentration of SO2, NO2, because you see the simplest thing is that organic carbon can be formed directly or can have secondary formation. So when you relate, you have a 10-year data of how organic carbon is changing in a particular location, let's say Delhi. Now, and what you can do is you can collect the other data. For example, you collect the temperature data, humidity data, you collect the gases data, SO2, NO2, all of that. and then you see how well they correlate with each other. And if the, let's say, the simplest thing you can see is that increase in SO2 would increase the concentration of OC, or how it's affecting how the temperature is affecting. So it depends on what type of access you have, or what, like, if you have idea that how the satellite and download and everything works. So huh huh not increase. See, the amount of sunlight that reach earth is same. It is increased for the ozone. Why? Because generally air to har jagah hai, oxygen har jagah hai. Now if a region is very polluted, then the energy that is coming, the solar energy that is coming, will be taken up by those absorbing aerosol which are there. So let's say I make you understand this the way. Let's say there is a 5 kilometer layer, and below it there is lot of oxygen there. Okay, and at this 5 kilometer there is lot of pollutant, lot of black carbon, organic carbon, gases which absorb light, all of that there. Now, when the sunlight is coming, these absorbing particle or pollutant is absorbing light. So the light which is coming from after that 5 kilometer is has a very low wavelength or low energy, you will say. Okay, so the light is same, but the pollution is decreased. So पहले अगर oxygen is getting, let's say, 10 molecules, not 10 molecules, let's say 10 photons of sunlight. Now because there is no pollution, it is getting, let's say, 20, 25, or 30 photons. So the more the number of photons, the more generation or the more breakdown of oxygen will happen, and the more generation of ozone will take place, like that. Okay, so we are done for today. And if you have no question, then I think we can end it. uh, I think this is the last session, so best of luck for your exams. And thank you everyone. Hanji, I actually don't have any, because see, we don't make the exam, we don't take the exam also. So the only purpose of us is to take these interactive sessions. So we don't have idea that how what was there in the, what will be there in the exam. So I don't think, but I think if you go through the lectures, I think that will be it. You don't have to need to read from any further books or anything. Okay, okay, then thank you.